All right, these are going to be our notes on balancing chemical equations. This is page 7 of the packet, so if you're not on this page, make sure you get here before you start on these notes. The top of these notes are just going through some rules for these types of problems. And to make this video shorter, I'm not going to read this to you, so if you have not read the rules through yet, pause the video here, read through them, and then we're going to do some examples using those steps. So take a second, pause, read those rules. All right. So you should have read through the rules. Now we're going to start on our first example here. And we're going to zoom in on number 1. Now, what I like to do to start these is write out all of the different elements that are in my equation. So going from left to right here, it looks like I've got an Mg. So underneath the arrow in the middle here, I'm just going to list that I've got an Mg. And then I've also got an oxygen. I've got an O. So I'm going to put that below the Mg. Okay, and then it looks like over here it's just another Mg and O. So we don't need to redo it when we've already written them down. So this equation is pretty easy. It's only got 2 different elements, Mg and O. But let's see if it's balanced. So on the left side, Mg does not have a subscript, and just as a reminder, if there's no subscript, it's just a little invisible 1 right next to it. So we're going to give Mg a 1 for the left side, and on the right side, it's also got a 1. There's a little invisible 1 there. So on the left, we've got 1, on the right, we've got 1. Oxygen on the left has 2, because it's got the subscript 2. So on the left side of that, I'm going to write a 2. And on the right side, it's got 1. So we're going to put a 1 there. Okay. So we've accounted for all of the atoms that are in our equation. And if we look, Mg looks nice. It's balanced. It's got the same number on the left and right. So Mg is all good. But oxygen is not. Oxygen only has 1 on the right side when it has 2 on the left side. So we need to figure out how to balance this. And the way that we're going to do that is over here, you'll see that there's a blank spot in front of MgO. We need to make sure that we give that one 2 more of that compound. Okay. And so now we're going to take that 2 and apply it to both of our atoms. So 2 times Mg gives us actually 2 on the right side. And 2 times 1 for the oxygen gives us 2 for the oxygens. And so now if we look, we are balanced on the oxygen. We've got 2 and 2. So now oxygen is good, but you'll notice it also affected our Mg. Now Mg is out of balance. So we need to account for that by adding in another 2 to the Mg on the left side. And so that's going to turn that one into a 2 as well. Okay. By doing that, now Mg is balanced and O is balanced, so we're all good. The only thing that's left to do, there's a little blank spot in front of the oxygen. Anytime that we're left with just a blank like that, it just means that that value is 1. Okay. So that's our first example. Let's go through another one. Here, I'm going to do the same thing I did for number 1. I'm going to write out all of the elements that are present. So I've got an aluminum, I've got an oxygen. And I really like this type of problem because as you get the hang of it, it kind of feels like you're solving a puzzle. So let's see how we solve this puzzle. Here we've got 1 aluminum on the left side, and we've got 2 aluminums on the right side. We've got 2 oxygens on the left side, and we've got 3 oxygens on the right side. So in this problem, both aluminum and oxygen are out of balance. And you'll remember from the rules, we're going to balance hydrogen and oxygen last. So since we've got an oxygen here, we're going to save that one for after we do aluminum. So aluminum, we need 1 more on the left side. So we need to turn this one into a 2. And by doing that, we balance our aluminum. Oxygen is kind of weird though. We want this left side to equal the right side, but we can't multiply this 2 by anything to equal the 3. Okay? We can't do 1.5. You can't have half of a molecule. So what we actually need to do here is find a common factor. And 2 and 3 is a pretty easy one. They have a common factor of 6. Okay. And so their lowest common factor will be 6. In order to get there, I need to multiply the left side by 3. So I'm going to give that O2 a 3. And this will actually multiply. So that's 3 times 2 gives us 6. The right side we need to multiply by 2, so we're going to give that one a 2. 3 times 2 will be 6. But we also need to multiply our aluminum. We can't just apply that 2 to the oxygen. So 2 times 2 actually makes this be 4 aluminum. Okay. And so by balancing our oxygen, now we've got 6 and 6. We threw our aluminum out of balance. And so instead of having 2 on the left side, we actually want to end up with 4. So I'm going to cross out that first 2 that we did and replace it with a 4. And that will make our aluminum nice and balanced on both sides. So our answer for this one would be 4, 3, 2. Okay, next problem down, number 3. This one is going to have our first polyatomic. So you'll notice that we've got NO3 in parentheses. To make these problems easier, whenever you see a polyatomic in parentheses like this, see if you can find it somewhere else. In this case, we've got another NO3 over here on the left. And so we can actually make this problem way easier by putting this in parentheses as well. And with it in parentheses, we can treat it as one unit. We don't have to do nitrogen and oxygen separate from each other, and it makes it all messy. It's just nice and easy NO3. So with that in mind, we're going to solve it the exact same way we did number 1 and 2. We're going to have an Ag. We're going to have an NO3. We've got an Mg. And we've got a Cl. Counting up on the left side, I've got 1 Ag, I've got 1 NO3, I've got 1 Mg, and I've got 2 Cls. On the right side, I've got 1 Ag, 2 NO3s, 1 Mg, and I've got 1 Cl. So, not looking too bad here. We only have a couple of things that are not balanced. The first one is our NO3. We want 2 more on the left side, and so since our NO3 is here, we're going to give that spot a coefficient of 2. So that 2 is going to apply to both the Ag and the NO3. So Ag is now getting out of balance a little bit with a 2, but the NO3 is getting balanced with a 2. So now NO3 is balanced, but we threw off Ag, so let's fix that one real quick. Now that we've got 2 on the left side, we also want 2 on the right side, so we're going to give this one here a 2. That 2 applies to both Ag and Cl. So that's going to turn our Ag into 2, and it's going to turn our Cl into 2. And this actually works out perfectly for us. It had the side effect of also balancing out our Cl. We wanted the 2 on the right side. So sometimes you'll get a situation like this where it'll balance for us. Okay. And so now everything looks good, and that would be our answer. So 2, and then remember blank spots just mean a coefficient of 1. We don't normally write 1 when we're actually writing out the equations, but for balancing purposes, a blank just means 1. Okay, so we are on to the last example here. I want you to try this one by yourself. Try not to look ahead in the video and just copy it down. Go ahead and try it by yourself and then come back to check your answer in just a minute. Okay, that one was kind of a tough one, but let's see how you did. We should have had, at the end of it all, 2, 7, 6, 4 is going to be what balances this equation. There was a lot of back and forth there, so we balanced some things, which threw other things out of balance, but at the end of it all, 2, 7, 6, 4 is what gets us a nice even amount of atoms on both sides of our equation. So once you are done with these notes, there is some practice on the next page. So you can always refer back to this video if you get confused and maybe want to hear me talk through it again. But besides that, good luck with your practice page.